Welcome to this video on one-sided limits. If a function f of x gets arbitrarily close to a value L for all values of x sufficiently close to a, we say that the function f of x approaches the limit L as x approaches a. We can write that the function f of x approaches the limit L as x approaches a in the following way. For example, shown to the right is a plot of the function f of x is equal to 3x. In this example, this function is defined on the closed interval from x is equal to 0 to x is equal to 2. As the value of x approaches 1, the value of f of x approaches 3. Ordinary limits are two-sided. To have an ordinary two-sided limit L as x approaches a function f of x must be defined on both sides of a, and its values must approach L as x approaches a from either side. In this example, the function f of x is defined on the closed interval from x is equal to 0 to x is equal to 2. It's defined on both sides of the point where x is equal to 1. As the value of x approaches 1 from the negative side of 1, through values less than 1, the value of f of x approaches 3. As the value of x approaches 1 from the positive side of 1, through values greater than 1, the value of f of x approaches 3 also. (3x) approaches the limit 3 as x approaches 1, and we write this in the following way. This limit is an ordinary two-sided limit. If a function f of x doesn't have a two-sided limit at a, it may still have a one-sided limit. A one-sided limit is a limit involving an approach only from one side. A right-hand limit is a one-sided limit involving an approach from the right. Shown to the right is a plot of the function f of x is equal to 7 minus x. In this example, the function f of x is defined on the open interval from x is equal to 2 to x is equal to 6. As x approaches 2 from the positive side of 2, through values greater than 2, the value of f of x approaches 5. We say that the function f of x has right-hand limit 5 at x is equal to 2. We write this in the following way. This notation for a right-hand limit includes a plus sign. This notation, now highlighted, means that x approaches 2 from the positive side of 2 through values greater than 2. A left-hand limit is a one-sided limit involving an approach from the left. In the same example shown to the right, as x approaches 6 from the negative side of 6, through values less than 6, the value of f of x approaches 1. We say that the function f of x has left-hand limit 1 at x is equal to 6. We write this in the following way. This notation for a left-hand limit includes a minus sign. This notation, now highlighted, means that x approaches 6 from the negative side of 6 through values less than 6. We can define right-hand limits as follows. Let f of x be defined on an open interval from a to b, where a is less than b. If f of x approaches arbitrarily close to L as x approaches a from within that interval, then we say that f of x has right-hand limit L at a. We write that f of x has right-hand limit L at a in the following way. We can define left-hand limits as follows. Let f of x be defined on an open interval from c to a, where c is less than a. If f of x approaches arbitrarily close to m, as x approaches a from within the open interval from c to a, then we say that f of x has left-hand limit m at a. We write that f of x has left-hand limit m at a in the following way. A function f of x has an ordinary two-sided limit as x approaches c if and only if it has left-hand and right-hand limits there, and these one-sided limits are equal. We read this symbol, now highlighted, as if and only if. It's a combination of the symbols for implies and is implied by. F of x approaches the limit L as x approaches c if and only if f of x has right-hand limit L at x is equal to c, and f of x has left-hand limit L at x is equal to c. Shown to the right is our earlier example function f of x is equal to 3x, defined in this example on the closed interval from x is equal to 0 to x is equal to 2. This function f of x has left-hand limit 3 at x is equal to 1. This function also has right-hand limit 3 at x is equal to 1. These one-sided limits are equal, so the function f of x has two-sided limit 3 as x approaches 1. Shown to the right is a plot of the piecewise defined function f of x is equal to x plus 2 for values of x greater than or equal to 0 and less than 6, and f of x is equal to x minus 4 for values of x greater than or equal to 6 and less than or equal to 10. This function f of x has left-hand limit 8 at x is equal to 6. As x approaches 6 from the negative side of 6, the value of f of x approaches 8. This function f of x has right-hand limit 2 at x is equal to 6. As x approaches 6 from the positive side of 6, the value of f of x approaches 2. These one-sided limits are not equal, so the function f of x does not have an ordinary two-sided limit as x approaches 6. To summarize, in this video, I've described and explained one-sided limits. I've covered left-hand limits and right-hand limits. I've also discussed the relation between one-sided limits and two-sided limits. If you found this content useful, please subscribe to the channel to receive more content. Thank you very much for watching this video. See you next video.